Now let's look at this example. You'll notice that we have the words maximizing area. The formula that we want to use is A equals length times width. Before we can use that, we notice we have too many variables, L and W. We need one of these to be in terms of the other. So that's where we use the other information given about a rectangular field. So let's just draw a rectangular field. And you're told that we want to, well, before we talk about the actual problem, remember with rectangles we have a length, two of them, and we have two widths. Now if this were just a rectangular field that wasn't subdivided, we'd be done. But we're told that we're going to subdivide it into three smaller rectangles by placing two fences parallel to the width. So we're going to subdivide it, two fences. And notice we have three rectangles that we're going to say are equal. What that means is, instead of having 2 W's, we now have 4 W's, which means that a formula for perimeter is no longer 2L plus 2W, it's 2L plus 1, 2, 3, 4W, because we have 4 widths. Now we're going to use this formula to solve for a variable and substitute into that formula so we can find the vertex because of the word maximize, which means find the vertex. And when it says find the dimensions, that means we need to find the length and the width. And we're also told we have 800 feet of fencing, and that's going to be our perimeter. So we're going to take the 800 and substitute it for the P. And it doesn't matter if you solve for L or solve for W, but I'm going to go ahead and tell you that we're going to solve for L because I don't like fractions. And I've looked ahead. If I solve for W, I would have fractions. It doesn't matter. I just don't want to work with fractions. So we're going to solve for L. And to do so, I'm going to subtract 4W from both sides. And that means I end up with 800 minus 4W equals 2L. Then I get the L by itself, I divide everything by 2. I divide each term by 2. That's the way I like to approach it. And you get 400 minus 2W equals L. Now remember, we're using the area formula, which is length times width. And if we're to have an L, I'm going to put 400 minus 2W. Then don't forget this W. So all we've done is substitute L with 400 minus 2W, and then the other W. And the formula for the area becomes 400 W minus 2W squared. Now that 2W squared helps us out a lot because that means we have a parabola, a quadratic equation, which means we can find the vertex. All I'm going to do right now is just rearrange it so we can see exactly what we're looking at in correct form. That means that negative 2 is our A and 400 is our B. And the reason why we're doing that is because, once again, we're going to find the x value of the vertex, because maximize or minimize means vertex, and all I need is find the x value for this particular problem. And the formula for that is negative b over 2a, and our b is 400, and our a is negative 2, which means that x is equal to negative 400 over negative 4, which is a positive 100. So that x is actually our width. Got that? So it's still the same process to find the vertices that you may have seen in other problems. It's just that our x happens to be our width. Now the only thing remaining to do, we need to find the length, because the problem asks for the dimensions. So I need to find a formula that associates the length and the width with this problem that has the information, and we're going to use this. Or you could actually use this, because it's the same equation. It already solved for L. So either way either one you want to use, that's fine. I'm going to use this one right here because it's already got the L equals. So what that means is L is equal to 400 minus 2W. And if you don't believe me, there it is, 400 minus 2W. And that means that once we replace the L, or the W I mean, which is 100, we get L equals 400 minus 200, and L equals 200. Keep in mind that the width was 100, and the last thing I want to make sure is feet. Always make note of the units, feet. So that's the final answer.